Hi guys, welcome to today's lesson. So right now we are going to focus on exploring different functions, right? So we're going to actually look at functions on their individuality and try to see what each function composes of and what are the key ideas whenever you're looking at those functions. But before, let's just look at the mapping of everything that has to do with functions that we are looking at. So remember, the big idea here is functions, and there's different types of them, which is what we're actually going to look at, each type of function. The definition, the main thing here for this lesson is what you call a turning point and an asymptote, as to what exactly do these things mean and how to go about understanding them. Now, as I said, the key word here is the turning point. Firstly, the first type of function we're going to look at is the quadratic function, which is a function of the form y is equals to ax squared plus q. Now, so the a and the q are normally constants. Remember, every function needs to be drawn on a Cartesian plane which has x and y. So that's why the y and the x are always there. You don't change them. But what we don't need is the a and the q. So that's what I'm saying. These are constants, meaning they are actual values, right? So a can be any real number. Q can be any real number. And then the graph of a quadratic function is normally called a parabola, right? So this is called a parabola, which we will look at the shape of it just now. Firstly, I want you to consider the graph of f of x is equals to x squared. Remember, the f of x is my output values. This is the output, and the x value will be the input value, right? So that's why I only give you the x values. I want you to find the f of x. So when x is minus 2, the value of f of x is going to be minus 2 all squared, which will give me a positive 4. When x is minus 1, it will be negative 1 all squared, which will give me positive 1. When it's 0, it will be 0 squared, which is equals to 0. And then 1, it will be 1 all squared is equals to 1. And then when it's 2, it will be 2 squared is equals to 4. Now, just to make a note about this as well, I know even sometimes we think we only need brackets when it's a negative value, but just so that you get used to it, please include brackets, whether it's negative or positive that you are substituting. Just use brackets at all times, so that even when you have forgotten that you must use brackets, it is just conditioned to you that whether it's positive or negative, I must have brackets. So you won't suffer from these things of making these clumsy mistakes that we make, where if it's a negative and then someone does not include brackets, it won't give you a positive answer in terms of when you press a calculate, right? So what I really mean is, if you say minus 2 squared and press this on your calculator, I promise you, it will not give you a positive 4. It will give you a negative 4, which is something different from what we need to look at. So please, this you must not do at all times. You must make sure that you include your brackets. Now, the graph is normally obtained by plotting the points on a Cartesian plane and drawing a curve through those particular points. Remember our points, this is supposed to be 4 there, just not 1. So if that is 4, that is 1, that is 0, 1, and 4. It means, firstly, I will start with minus 2. From minus 2, you know it's 0, you move 2 units to the left. At minus 2, you move 4 units up. So it will land you at this particular point there. And then minus 1, you move 1 unit up, it will land you at that point. 0 with 0, 1 with a positive 1, 2 with a positive 4. And then you just join these points like this, right? So you just join them, and then it will give you a curve like that, right? So at the end, we normally indicate the end of the graph with an arrow to show that this is actually going to continue indefinitely. We just used few values here, not all of them, right? Because remember, a number line continues up until positive and negative infinity. If you draw it up to scale, it will look like this, which is more or less the same as what I just showed you now. Now, all output values are positive. Why are they positive? Because of the squared that I have there. So you can see all the output values is positive. 1 is 0, 2 there if I want to use it, 3 there, and there's a 4 there, and then you know there will be a 5 there. So all the output values will all be positive. And then the graph, we call it a parabola. So this is called a parabola. Right, so you need to, why we call it this is because we're not going to be using the word quadratic function going forward. It will be draw the following parabola or analyze the following parabola. So that's the word we are going to be using going forward. Now, the domain of the graph is normally given by x is an element of real numbers. Why I'm saying this is because the x squared makes it a point that all the x values that are on a number line, because they are real values, they are all defined, they are all valid on this particular graph, right? So that's why the domain will be x is an element of real numbers. Remember, domain is a set of all the input values where the graph is defined. So it means on the number line of the x-axis, whether you go to positive infinity or negative infinity, all the numbers are defined. They are all valid. But with the range, we then need to limit this, right? Remember we said all the output values are positive. So it means all the output values are, number 1, greater than the 0, meaning they are positive. Number 2, they also include the 0 itself. So I will say the range is y is greater or equal to 0. This simply means that 0 is part of the y values, and then anything else that is positive will also be part of the y values. Now, also, I know that maybe some of us, it might be the first time we're seeing the letter element of. Element of would just mean a set of all these values that are there. And then this is also normally written as y is an element of. Remember we said 0 is part of this, so I will have 0 there, a semicolon, and then I say this is to infinity. And then you leave it like that. Why this is a square bracket is because 0 is part of the answers. You always start with a small number and go to the biggest number. And the biggest number here is infinity, which we do not know. Now, when you talk about the shape of a parabola, the value of a, right, in this equation, the general equation, determines the closeness of the arms of the parabola to the y-axis. So you do need to understand this, right? So it means if a maybe is small, it will be this particular close, and then if it's big, you'll find that it's a bit wider like that, right, from the y-axis. I know I'm not drawing it to scale, but it gives you an idea of what we really mean. The larger the value, the closer the arms are to the y-axis. So if it's 2x squared compared to 4x squared, this will be a bit wider and this will be a bit close. So this will be maybe something of this nature, and then if it's 4, it will be a bit closer now to the y-axis. So the arms will be a bit close to the y-axis. And then the sign of A will cause what we call a reflection in the x-axis. Now, we normally use the word happy face and sad face, right? And I will show you why we say that. If A is a positive, the parabola is called a concave up, which we say is a happy face. Why it's a happy face? It's because it is forming a smile, right? So it's a curve that is facing up like this. So it is forming a smile, which is a happy face. So that's why we are saying it's a happy face, just for you to understand and see it visually with your eyes, right? Then, when it is less than 0, it is normally said to be concave down, which we say is a sad face, right? So it will be facing that way. Now, we also have what we call the turning point, right? The turning point is where the graph is going to change direction, right? So it is where it is going to turn, as the word itself says, turning point. It means that it's where, so the graph will go, it will get somewhere where it curves a bit, and then it changes direction, and now it goes up like that. So the turning point will be where it is just turning to change the direction. Normally when A is positive, meaning greater than 0, the turning point is normally said to be the minimum, and then when it is concave down, which is a sad face, the turning point is said to be a maximum, because that's the highest point of the graph. Guys, I hope you are enjoying this as much as I am. But for now, I want us to take a quick ad break. When we come back, we'll look at one other function and see what it is all about. Please stay tuned. Hi guys, welcome back to our lesson. So we are still looking at exploring different types of functions, but for now we need to look at the hyperbolic function and see what is the general equation and how to go about trying to draw the particular function. So let's just jump right into it. Now, the key word here is what we call the asymptote. We're going to explain what this is all about at a later stage. And an asymptote is just a line, but what makes that line specific will be what we're going to talk about. Now, a hyperbolic function is a function of the form f of x is equals to a over x plus q, where the a value and the q value are also still constants, right? So they can be anything. The a can be 2, can be 5, can be negative 10. It does not really matter as long as it is a real number. And then the graph of a hyperbolic function is called a hyperbola, right? So hyperbola. Some people normally make the O sound like it's silent. Now consider the graph of f of x is equals to 1 over x. So the a value is 1, the q value is 0. If I want to plot this, I must first calculate what the y value will be. So this will be 1 over minus 2, which is the same as negative half. And then the second one will be 1 over minus 1, which is the same as negative 1. This one will be 1 over 0, which right now I dare you to press your calculator. If you find an answer for this, it means your calculator is very smart, but this is actually undefined. So this doesn't, we don't have a value of x being 0 on this particular graph. So there is no point where x can be 0. Similarly with where y is 0. And I will show you why y cannot also be 0. And then 1 over 1, you know that will just be 1. 1 over 2 will just be strictly 1 over 2. Now, just to quickly go back to what I just said, x cannot be 0, number 1. Even y cannot be 0. Because if you make y 0, it means this will be 1 over x is equals to 0. When you calculate this, the x must be multiplied by the 0 there, which will be 0 is equals to 1. There is no way that you will solve anything there. So, in terms of this, x cannot be 0 and y cannot be 0 for this particular graph. And then, as we've been doing with the previous graphs, the graph of this can be obtained by plotting all these points on the Cartesian plane and then join them using a curve, because this is not a straight line, so we can't say join them using a line. Now, to do that, I'm just going to show you how to go about doing it. Although I don't have the half, I'm just going to make it the middle part of between 0 and -1. So negative 2 rather goes with negative half, which will be somewhere here. And then negative 1 goes with negative 1, so that will be somewhere there. And then 0 is undefined, so I don't have anything that is to do with 0. If I join this, I've just showed you 2 points. If there were 3 of them, this is how it would look. And then on the other side, 1 goes with 1, so there's the point there by 1 and 1. 2 goes with a half, which is somewhere in the middle there. And then just so that you can see how it becomes this, if I use half here between 0 and 1 as x, that is. So if x is equals to half, it means y will be equals to 1 over a half, which is equals to 2, right? Because there's 2 halves in 1. And then similarly with negative, it will still be negative 2. So for negative half, it will give me a negative 2, which will be somewhere there, you see. So that's where my point is. And then I will have my arrows there. For a positive half, which is somewhere here, it will go with a point up until it goes to 2 there. And if you join these, then it will look like that with my arrow there and my arrow there. But if you do it to scale, it will then be a graph that looks like this. Now remember, when x is 0, it means that the graph is crossing through the y-axis. But with this one, as we said, x cannot be equal to 0. Similarly, y cannot be equal to 0. So you can see that these 2 arms of my graph, they do not cross either one of the axes, the x-axis or the y-axis. Why is that? This is because of the concept of an asymptote. The asymptote will be a straight line that the hyperbola approaches but never touches. Let me show you. Going back to this, you can see the arrow. If I was to draw this a bit more, let me just do it here so that I can extend it and you see. So if I extend this like that, this graph will go close and close to the y-axis, to the x-axis, but it will never cross the x-axis. Why? Because x or y cannot be 0. So it cannot cross any of the axes. As soon as it does that, it means it is now no longer a defined graph. Similarly with the y, if it goes up there and I extend this, it will approach and approach and approach, but it will never cross. So that's what we call the asymptote. And there is normally 2 asymptotes, right? With a hyperbola, there's 2 asymptotes, which is the horizontal and the vertical asymptote. Going back to my graph again, it cannot cross the y-axis, which is the vertical asymptote, right? So it's x equal to 0. So on the y-axis, this is x equal to 0. And then it cannot cross the x-axis. That's where y is equal to 0. So my 2 equations, if the question says to you, state the 2 equations of asymptotes for this graph, you will then say x equal to 0, y equal to 0. Why? Because it cannot cross that particular line. I'm not saying when you say x equal to 0, y equal to 0, you are saying on the graph there is 0 and 0. No. You are simply saying the x equal to 0 line, the graph can never cross that particular line. The y equal to 0 line, the graph can never cross that particular line. So that's what an asymptote is all about. But it can go as close as a few inches between the two, but it will never cross it. That's what the asymptote is all about. And then to represent an asymptote on a graph, we normally use a dotted line, right? Although with this one, it does not really have the dotted line. We normally use the dotted line. And why that is the case is because of the Q value. So the horizontal asymptote is normally the Q value. So remember, my equation was x, 1 over x. And this means it is plus 0, right? So the 0 part, we don't write it because 1 over x plus 0 is 1 over x. So if it was something else, maybe 1 over x plus 2, right? The horizontal asymptote will be at 2. So it means that when I draw my graph, so this will be my axis, and that will be my y-axis. And then where there is 2 on the y-axis, I will draw a horizontal line that is dotted, and then I write y equal to 2. And then because this is a positive graph, it will be like that, and it will be like that, right? So you can now see that this graph is possible. It's possible for the hyperbolic graph to cross either the x-axis or the y-axis, but it depends on what the asymptotes are at the time. So my asymptote here will be the horizontal line that I've showed you with a dotted line. At times there will be 2 of them, both the vertical and the horizontal that you will see. Maybe the vertical there at x equal to 1 and the horizontal there at y equal to 2. So it means it will be there and it will be there, right? So that's just how you see the asymptote value. We use the dotted line on the graph. So you please need to make sure you understand this. How am I going to ask you about the asymptote? I'm going to say to you, state or write down the equations. Why I'm saying equation is because you're always going to say either x or y is equals to something, right? So the equal part is what makes it an equation. So please just make sure. And then at times, as we saw on this one, just to go back, you see it with a dotted line if you don't know what the equation is. So just make sure that you do pay attention to that. And then also, the value of A normally tells us where the graph is going to be, which is the vertical stretch. The larger the value, the further the stretch. Now, if it's positive, it's 1 and third quadrant. And then if it's negative, it's second and fourth quadrant. The A value is what is on top there, right? Remember that. So you need to please also know that. So this just gives you an idea of where the graph is going to be without you even drawing the graph. Hi guys, welcome back to our lesson. So we are still looking at exploring different functions. Now we are going to look at an exponential function and try to see what it is all about, what is the general equation, how do we change it, and when we change it, what happens, right? So let's just look at that together. Now, an exponential function will be a function of the form f of x is equals to ab to the exponent of x plus q, where the a, the b, and the q are constants, right? And then the exponential function has one asymptote. Now, if you remember correctly, whenever we look at a hyperbolic function, we say it has two asymptotes, but with this one, it only has one, which is normally the horizontal asymptote. So this only has the horizontal asymptote with it, which is the q value. Now consider the graph, or the equation rather, f of x is equals to 2 to the x. If my x is minus 1, this is going to be 2 to the exponent of -1, which is 1 over 2. And then when my x is 0, it will be 2 to the exponent of 0, which is equals to 1. Then when my x is 1, it will be 2 to the exponent of 1 is equals to just 2. Now, if I want to plot this, right, as I said, to plot this, my -1 goes with a half, so it will be somewhere there, which is a positive half. And then my 0 goes with 1, so it will be somewhere there. My 1 goes with 2, it will be somewhere there. And then roughly when you join the points, it will then be something of that sort, right? So you can already see that the horizontal asymptote, it means that it can never cross there, right? It can never cross the x-axis. So for it not to cross the x-axis, it means y is equals to 0 there. So y can never be 0, right? Although it is confusing when I say y is equal to, it means the equation y equal to 0 is where the graph cannot cross in simple terms. That's what we mean. And then the x-intercept is calculated rather by letting y equal to 0. So you can see, since there are no values for x where 2 to the exponent of x must give me 0, the conclusion will be y equal to 0 is the asymptote, right? So this is the asymptote of this particular graph. And also, it does not have the x-intercept. So in simple terms, there is no x-intercept. Now, another type of an exponential graph will be where the b value is a fraction, right, between 0 and 1. Same concept. If I substitute -1 there, this will give me 2. If I substitute -1 by the 0 by the x there, it will give me 1. And then lastly, if I substitute 1, it will then give me 1 over 2. Just so that you can see, it's 1 over 2 to the exponent of -1. This will give you 2. 1 over 2 to the exponent of 0. This will give you 1. And then 1 over 2 to the exponent of just +1, this will give you 1 over 2. So that's where I get my values. But you guys can always just press your calculator and it will give you those answers. To plot this as well, the -1 is the one that goes with a 2, so it is up there. The 0 goes with the 1, it is somewhere on the y-axis there. And then the 1 goes with a half, so it will be somewhere here. And then when you join this, it will look something of this nature here. Right? Still, you can still see that this is not crossing the x-axis. So it means it does not have the x-intercept. Now, as I said, the x-intercept, we know, is calculated by letting the y be 0. But there are no real values for x for this thing to be valid. There is no way that you can write 0 as a base of a half so that you can equate the exponents, because that's what the rule of exponents is. So the conclusion will be y equal to 0 is the asymptote, right? Asymptote. And then the other important thing is that there is no x-intercept. Is there y-intercept? Yes, because this graph is crossing through the y-axis there, right? So only the horizontal axis that the graph is not crossing through. Now, when we analyze the shape of an exponential graph, what does the a value do and what does the q value do, right? So firstly, the a shows us what we call the vertical stretch of the graph, right? Vertical stretch meaning it becoming a bit stretched vertically, right? And not really enlarged in terms of horizontally, no, stretched vertically. And then the value of q represents the shift of the graph up or down, right? Shifting means you are moving the graph. So if I say this is the mother graph, right? If I say this is the mother graph, and then I shift it upwards. When I shift it upwards, it will still be the same, but just a bit higher than it. Or shift it downwards, it will still be the same thing, but a bit down there. So although my graphs might not be drawn to scale, but that's really what I mean. And then the value of b in the equation represents the shape and the steepness of the graph. Shape, why? Let's go back quickly to what we've had, right? Remember when it was positive, when it was a value that is greater than 1, which was 2, the graph was moving from left to right and it was going up, right? But as soon as it became a half, which was between 0 and 1, it was still moving from left to right, but now it was going downwards, right? So that's what the b value does. Now, to be particular with this, if b is greater than 0, we say that the graph moves upwards from left to right as the x value increases. In simple terms, guys, as you are moving from left to right with the x, right? If you are moving from left to right, you're starting from the negative side and going to the positive side. So clearly the x value is increasing. And this graph we're saying is moving upwards, so it will then be something of that nature like that. But as soon as it becomes between the 0 and the 1, and why are we only focusing on between 0 and 1 and not less than 0? It's because the b value can never be a negative. There is no way that you will say your graph, the b value, which is the base of the exponent, is a negative. From your lessons about exponents and your knowledge of exponents, there is no way. I promise, if you do that, it means you are very smart, but in a very wrong way, because you cannot have a base of an exponent as a negative. So please just make sure you understand that. So it can only be between 0 and 1. As you saw, it was a half, or it can be a quarter, or it can be 3/4, as long as it is just between 0 and the 1 there. And this will then say that the graph moves downwards from left to right. As what? As the x value is increasing. So graphically, this will look something like this. We said it is moving down, so it is like that. And although it has arrows on the end points of it, someone might say, how do I know that it is moving down or up? We are judging from left to right. So if I move from here and go to the right, you can see the graph is going down. If I move from here to that side, you can see the graph is going up. So that's how we are gauging it, even though it still has arrows at the end point. And then lastly, as the value of b decreases, the graph gets steeper. Now, let me tell you, we then normally call this first one, when b is greater than 1, we call this the increasing function, right? This is called the increasing function, which you need to know, because at times the question might be, is this increasing or decreasing? But with this one, this is a decreasing function. This is decreasing. And then why are we saying increasing and decreasing? Is because we are mainly looking at the y value, right? So as x is increasing, the x value are increasing, the y value is also increasing here. You can see, because it is going up, right? This is also increasing. And then with this one, as x is increasing, the y value is decreasing. So how do you judge that the graph is increasing or decreasing? You look at the y value. If the y value is increasing as the x increases, then it's an increasing function. Vice versa, if the y value is decreasing, x is always increasing because you are always moving from left to right. That will then be a decreasing function. Guys, let's take a quick ad break. When I come back, we are going to look at how do you then try to look at the functions together in one plane. How do you explore them as one plane and two different functions? Please stay tuned. Hi guys, welcome back to our lesson. So we are still looking at exploring different types of functions. Now we're going to look at if it's two functions in one plane, how do you then talk about them? What are the key ideas that you need to see there whenever you're looking at it as it's one plane, Cartesian plane, and I give you two graphs, maybe a line graph and a parabola. How do you then talk about them? How do you analyze, or how do you even find where they're intersecting each other, right? So remember that. This is going to bring in some nice algebra that I know that you are familiar with, which is simultaneous equations. But let's have a look at it. Now, firstly, the point of intersection, which is what we need to first know. So intersection of two lines. This is where the x and the y values are equal to each other, right? So in simple terms, if I say to you f of x and g of x are intersecting each other, it means you can then say at the point of intersection, f of x is equal to g of x, right? And then you know that if you say f of x is equal to g of x, you will be only left with x, and then solve for the x, take one of them, substitute the x, and solve for the y. That's the simultaneous I'm talking about, right? On a graph, consider this graph. So you can see that with these two graphs of mine, which are just line graphs, the first one here, if I want to make it a normal equation, it will be y is equals to 3x over 2 minus 4, right? And then with this one here, it will be y is equals to negative 2x plus 3, right? So if you just solve them, by the way, you divide everything by 2 and then get rid of all the letters and leave y on its own. That's how I got those two equations. For me to find this point, it means I must equate these two things. So I will say, I will call this one the f, and then I will call this one the g. So it means I will say that f is equals to g in order to find where they are intersecting. And this will be 3 over 2x minus 4, and this must be equals to negative 2x plus 3. And then quickly, let's just solve for this. I'm just going to solve the x, and then the y will substitute it. If I solve the x, it will be 3 over 2x plus 2x is equals to 3 plus 4, right? So I took the x to the left-hand side, the constants to the right-hand side. And then I will multiply everything by 2 in order to get rid of the fraction, which will be 3x plus 4x equal to, this will be 7. Multiplied by 2, it will be 14. So this will be 7x equals to 14. Then my x will be equals to 2. Let's just go verify. We use a different color so you can see the point of intersection is actually at x equal to 2. How did I get the y? It will be, you use any of the equations you want. So let's maybe take g because it's easier since it doesn't have a fraction. It will be y is equals to minus 2 into 2 plus 3. So minus 2 by 2 is negative 4, plus 3 will be negative 1. So you can see negative 1 is there. So that's how you then find this, right? So what do? Equate them and then solve simultaneously. So as I said, the point of intersection of these two graphs will be at 2 and minus 1, as I showed you the working out. Now, the point of intersection of these two graphs, it being at 2 and minus 1, means that the x is equals to 2 and the y equals to minus 1 are said to satisfy the equations simultaneously, right? So if I plug them simultaneously into the equation will always be true. That's what satisfy the equation really means. So in simple terms, if I said to you, find the point of intersection of these two graphs, you will solve them simultaneously and you will get the values that satisfy them in that particular way. And then a linear and a quadratic system now, if I combine a linear graph and a quadratic graph, these can be represented by a line and a parabola in the xy plane, right, in the Cartesian plane. And then each intersection of this, right, which is the line and the parabola, represents the solution to the system. Solution in what sense? Where the graphs are intersecting one another. Let's make a typical example with this. If I give you f of x and g of x, when x is minus 2, this will be minus 2 plus 1, which is minus 1. If it's minus 1, it will be 0. If it's 0, it will be positive 1. If it's 1, it will be 2, and then it will be 3, right? That's only for f. Let's go for g. For g, if it's minus 2, it will be negative 2 squared minus 1, right? Which will be 4 minus 1, and that is 3. And then negative 1 squared will be positive 1 minus 1, that gives me 0. And then 0 squared minus 1 will be at minus 1. And then 1 squared minus 1 will be at 0. Right? 1 squared minus 1 will definitely be at 0, yes. And then 2 squared minus 1 will also be at 3. And then if I plot my equations, then it will look like this, right? So minus 2 goes with 3 there. 2 goes with 3 as well. Negative 1 goes with 0, and positive 1 goes with 0, and then minus 1 goes with that. And then my straight line will be that. So visually, this graph, you can see that they are intersecting at this point and at that point, right? But if I did not give you the graph, how would you solve those? You would quickly equate these and solve, right? So let me show you. Firstly, we'll say the point of intersection of these two graphs will be, as we said, minus 1 with 0 and 2 with 3, right? Because we can see them on the graph. But if I did not give you that, how would you do it? So you would quickly say f is equals to g, remember that. And that will be x squared, so it will be just x, not x squared. That is the f, right? So it will be x plus 1 equals to x squared minus 1. You solve this, guys. This becomes x squared minus x, and then minus 2 equal to 0. You solve this, it will be x minus 2x plus 1 using factorization. So my first x value will be at positive 2, and then the other one will be at minus 1. So let's see. There, that's negative 1, where is 2? There, so it is intersecting at 2 there, you see. And then you can substitute this in either one of the two equations to get the y values. So the point of intersection of these two graphs is not only at one point, right? It will be at minus 1 with 0, and it will be at 2 with 3, right? So you please need to know that. How do I find the point of intersection again? You equate the two equations. Equate the equations, right? So please just note that. Now, when they want you to analyze the two graphs, they will say, what does f of x greater than g of x or f of x less than g of x? What is the value that satisfies that condition? Now, I want you to understand what this means first. It simply means that f is above g. That's all. With this one, it means f is below g. Right? So we go to the graph. Let me just change my color so I can highlight for you. Where it is above, I will start with the point of intersection. There's the point of intersection, right? I want where f is above. And remember, the f was the straight line. So where it is above, if you look at this region here, the g is above, the f is below. So it does not satisfy that. But here, the f is above, the g is below. The g is above, the f is below. So it is between those two values where that thing is true. With the second one, where f is below, it means that it will be wherever I didn't say it works. So this is number 1, and this will be for number 2. How do I write that solution? You will write the solution as, for this first one, it will be x must be trapped between 2 and minus 1. So in that region, this thing is satisfied. And then for this one, it will be x must be less than -1, or my x must be greater than +2, and that will be satisfied. So that's how you analyze this. If they include a bar, you know they're just talking about equality. Then you can talk about them being equal. Now, just to summarize what we've looked at, remember every type of function has its own graph with a particular shape and unique features. Some have 2 asymptotes, some have 1, some have a turning point, some do not have a turning point. And then you need to look at the shape and the features of the parent graph and see how it moves and becomes the other functions. Guys, I hope this has clarified a few things about functions and how to look at them. Please remember, if you don't understand something, try to write it in simple terms, in simple English. Like f greater than g means f is above g, and then you will understand it. From me to you, the Maths Doctor, I hope you've been having fun as much as I have. Until next time, but remember, maths is food for the soul.